Hello, everyone. I'm glad to be here. So in this presentation, we will talk about NATS, obviously, and especially about a new feature that is coming to the NATS ecosystem that allows to run workloads with NATS. So quickly about me, Juggery, developer relation engineer at Exoscale. I joined Exoscale 1 year ago. And before that, I was working in kind of startups in the southern of France, south part of France. I was mainly DevOps, cloud architect, and at the same time, I was also, for a couple of years, Docker and Kubernetes trainer. I've added a link toward my personal website. You'll find there mostly information about Kubernetes and some CNCF project. So I'm not a sales guy, so I will be quick on this one. But just for you to know, Exoscale, if you don't know, it's a European cloud provider, and we are providing all the building blocks that you may need to deploy and to manage your application in production. VMs, Kubernetes, managed databases, object and block storage, and GPUs as well. We have currently 8 data centers across Europe, Germany, Austria, Switzerland, Bulgaria, and Croatia. And we have a strong focus on compliance with several security certifications that you can see on the top. And we have also a strong focus on sustainability. We have a booth there, so you can come to say hi if you want. That's it. Why a talk about NATS? So I'm not working at Synadia, which is the company behind NATS. I'm not a NATS contributor, but I'm a user who really like this piece of technology. I really like NATS. I use it in various projects, could be personal and professional projects as well. And also, well, I'm a big fan of Kubernetes, but I'd like to explore some other ways to manage workloads, and this is the promise of NEX, which is NATS execution engine, the new feature in the NATS ecosystem. Quick history about NATS. So just who is using NATS? Yeah, okay, not that much. Okay. So NATS is started as a message broker, like publish, subscribe. We will see it in action in a couple of seconds. It was created in 2011. It was donated to the CNCF in 2018, so that's quite a lot of time. It's currently in the incubating stage in the CNCF, and it's used by many companies. If you go into the nats.io website, you will see a logo of big companies, well, a lot of companies from any size, in fact. NATS has evolved in these feature sets. It started as a communication layer, it is a message broker. Then the contributor has added a storage layer. The name of the storage layer is Jetstream. And the new kid on the block is the workload layer, which allows to run workloads with NATS. So just keep in mind that this is experimental, so the API may change. We will focus mainly on this last workload layer. So first layer, the communication layer, is the message broker. For example, you will have several patterns that are available in NATS. The first one, top left, is the publish subscribe, maybe the one that is the mostly known. You have a publisher, and this publisher will send a message on a specific subject, and then you have some subscribers that will subscribe to this subject and receive the payload. This is a basic publish subscribe. You have another pattern, the one below, when you have a publisher sending a message on a specific subject, but the subscribers are part of a queue. That means that only one subscriber will handle the message. So another pattern. And you also have another pattern, which is the request reply. Request reply, you still have a publisher sending a message on a specific subject, but this publisher will wait for reply. And one of the subscribers will reply to this publisher. This pattern is very interesting because it can be used in several use cases. Instead of HTTP requests, for example, between the communication between microservices. So specific use case when you could use this one for microservices to communicate instead of HTTP. NATS comes with the NATS CLI, and this NATS CLI contains all the commands that you may need to test NATS to see how it's working. So we will use those NATS pub sub reply requests just for you to have a quick understanding of what we can do with NATS. Obviously, if you want to use NATS in your own applications, you will use the SDK, Java, Go, Python, whatever. But it's very handy to use those NATS, this NATS CLI, just to illustrate how NATS is working. So I will just show you. Here, I have a couple of terminals. Let me find my mouse. Where is it? Here. I will start by running 3 subscribers. I can do this very, very easily with NATS sub. I will subscribe to the echo subject. That's all. I will do that in the other terminal as well. Echo. So this means that each time a new payload message will be sent on the echo subject, then those subscribers will receive the message. I can do a NATS publish on this echo subject with hello, and we can see that all the subscribers receive the message. So this is the basic publish subscribe. What we can do to illustrate the second pattern is to use a queue, like workers, for example. We do the same thing here. Yep. Queue, workers, yep, and the same thing here. Queue, workers. So now the subscribers are part of a queue. That means that each time I will send a new message from the publisher, only one subscriber will handle the message, I should say. And this is basically round-robin stuff. So this is just to illustrate the way this queue pattern works. And once again, if you want to use this kind of pattern in your application, you will need to use the SDK for that. But the NATS CLI is very handy to illustrate how this is working. And the last one is the request reply. So what I can do is to run a subscriber with a reply here. I can, yes, and it will reply on the echo subject. And each time it will receive a new message, it will just echo this new message. And I will run exactly the same thing here. That's reply dash echo, and same thing here. Okay. And now, when a publisher sends a message waiting for a reply, it will use the request reply pattern. So it will just do a NAT request. It will send a message on the echo subject, and we'll see that he received the message, the reply back here. So this is just to illustrate the 3 patterns that we can use in NATS, and the NATS CLI makes it really handy to demo those things. Yep. This was the communication layer. For the storage layer, you have something that is called Jetstream that has been added later on. It's built into the NATS server, so that means if you want to run a NATS server, if you want to enable Jetstream, it's just an option in the configuration file that you need to enable. And this Jetstream persistent engine will allow to store the messages and to replay the messages. Because in the communication layer, the demo I've just done, if you have a publisher sending a message, but if you don't have any consumer at the other end, then the message is just lost. So if you want the message to be stored somehow, you will need to use this Jetstream layer. And you have 2 main objects, I should say. Streams. Those are an object that will allow to store all the message on a specific subject. And you have also consumers that will allow your NATS client to consume the message after they are stored in the stream. You have dedicated function for that, in command for that in the NATS CLI, which are a NATS stream and NATS consumer. And one thing that is very interesting in NATS, it's that on top of this Jetstream persistent engine, which is there to store the messages, is that they have built some other storage solutions, like KV store and like an object store, which means that if you have a NATS client, your NATS client can persist some data in the KV store, internal KV store, handled by Jetstream, and also in the object store. And we'll see that on the demo later on. I will just introduce those quickly, those things here. So the NATS, I didn't say that, but the NATS server that is running, the one that I'm connected to, is running in the Docker container with a specific flag to enable Jetstream. What I can do, here I will just close those things. Yep. I can do a NATS stream ls. There is no stream, but I can easily create a stream with NATS stream add, and I can just specify here name of my stream and a subject. Subjects equals orders.star, for example, and I will keep the defaults. I've just created a stream. So this is something that will allow NATS to save all the messages that are sent on orders.something. What I can show you, if I publish a message on orders.new, for example, and say that someone is interested in the item 123, and I will create a couple of orders. Yep. I can check the NATS stream, ls, and I can get some info. Well, I can have some additional information, but you can see that we have 3 messages on the stream, so this stream is there to store the messages. That's all. Then we can use what they call consumers, and consumers is something that can be created. I will create a consumer on the stream orders, and I will give this consumer the same name, orders, and I can specify a target. That means each time a new message will be sent on the order.something, then the consumer will send this message on the specific target, which is another subject named order in my example. I will keep all the other defaults. Okay, so what I can do now is to create a client, one subscriber, on, for example, order, without any S here, and that's all. And I can see that in this one, the new subscriber that I've joined the cluster, we say, I've received all the messages that were submitted when it was not online. So this is just a quick illustration to show you how we can create stream, or we can create consumers to make sure that the messages are not lost. And so it's very handy to use this kind of thing in environment when your subscribers or consumers are not always online. Yeah, and another thing I can show you is the object and KV store, which are built on top of Jetstream. This is very, very handy to have this kind of storage embedded into NATS. For example, if I do a NATS KV ls, there is no bucket. A bucket is the kind of namespace to manage a couple of key values. So I can, for example, create a new bucket. It's add demo. There's a new bucket, and inside this bucket, I could do some put demo key 1, value 1, for example. Value 1. Just a matter of creating a bucket and then adding content in the bucket. So once the content is there, any NATS client can access the bucket and get the information from this bucket. If I do a NATS bucket kv ls and ls demo. Sorry, demo. I see that this bucket contains now a key, and I can get this key 1, and get the value of this key. So just an embedded KV store that you can have directly when you use NATS. And the last one is the object store. Object ls. Don't have any bucket here, but I can easily create one. Same thing, I will call it demo. And what I can do is to create a file, test.empty, for example. It will be an empty file, but I can then put this file into this demo buckets, test.empty. And if I have a look at the object store and inside the bucket demo, I can see the file is there now. So this is another thing that is built on top of Jetstream. You directly have access to an object store. Very, very handy if you want to store some file, obviously. So this was an illustration of what you can do with the storage layer, store and replay messages, and also use the KV store and the object store that are available inside Jetstream. Sorry. Yeah. The next layer is NATS execution engine. The name is NEX. And this one is quite new. It allows to deploy and to run workloads on what they call NEX nodes through NATS. There is a specific CLI for that. This CLI is NEX. And in terms of workload, we can deploy services, which are long-running processes, but we can also deploy function, so short-lived, event-triggered processes, pretty similar to Lambda. If we want to get started with NEX, what do we need? We need a NATS server or NATS cluster, but we need to have Jetstream enabled into this NATS server. We need a couple of NEX nodes, or just one NEX node, which are nodes, let's say VM, that can connect to the NATS cluster or NATS server. We need to deploy a function using the NEX CLI, and then we need to invoke the function. This is what is represented on this schema. If we have a closer look into a NEX node, this is what it looks like. This is the architecture diagram you can find on the official documentation. The NEX node is the node where your workload will run. And your workloads, or function or services, will run in isolated environments. These isolated environments are Firecracker micro VM. And also, the NEX node exposes a control API that allows to deploy workload through NATS. It's very important to understand this Firecracker micro VM because this is a way to run kind of code that we don't trust, for example, and to use those micro VM with the hardware isolation. So this is the default behavior to have workload running into the micro VMs. Inside each micro VM, you have a NEX agent, and this NEX agent is the one managing the workload, running into that VM. This NEX agent acts as a bridge between NATS and the workload running inside the VM. This is the one that will receive the message, that will run the workload, and that will also send the reply back to the client. So it was just for you to know a little bit more about what's inside this NEX node. In terms of workload, we can run services, which are log-running processes, APIs, whatever. Those services can run in sandbox mode, which means it will run in a Firecracker micro VM. In that case, it needs to be statically linked Linux binary. It can also run in no sandbox mode. In that case, it will run directly on the host. So it could be Linux, macOS, or Windows binary. We can also run function, and we'll mostly talk about function in this presentation. Functions are short-lived processes, can be compared to AWS Lambdas. They are triggered by a message on a specific NATS subject. same as for services, the function can run in sandbox mode, so inside a micro VM, or in no sandbox mode. In that case, it will run on the host. The function needs to be implemented in JavaScript or compiled in WebAssembly. This is currently the two ways that we can deploy those functions in NIX. So, quick demo. In fact, it's more about setting up the environment for the demo that I will do alongside the slides. I have created 4 VMs. In the first one, you have a NATS cluster or NATS server running. Another VM is a NEX node when I will run workloads. There is another VM that I call admin. I will use it to deploy the workloads, and another one that will just act as a simple NATS client. So this is something I will show here. I have a couple of VMs I have created. So the NATS one, it's still also running in a container. Next one. So this is a next node. In this next node, I have installed the next CLI and also already run the pre-flight command that download all the things that needs to be downloaded. Firecracker binary and a couple of libraries for networking purposes. And once everything has been created, or downloaded, I can just set up the node like this. Okay, so the node is running. So that means it's ready to receive workloads. I SSH into my admin VM, and inside this VM I have a folder with different kind of function that I will show you just after, and a client that will act as a simple NATS client. So this is just the setup of the demo, and I will come back to this in a couple of minutes. If I want to deploy a JavaScript function, this is a very simple example of JavaScript function that I can deploy with NEX. So echo.js. It basically just sends a JSON with the subject and the payload it receives. That's all. If I want to deploy this function, I can use the next CLI, next devrun. Devrun is a very handy command if you are in development mode. It will manage all the security key for you, for example. Then I will provide the name of the file. I will specify the subject this function should be triggered on, and the type of the function. I will come back to this later on. And once the function is deployed, I can just send a NATS message on the specific subject, on the subject related to the function, to invoke the function. So this is something I will do here. I will go into the JS. The echo.js is there. Maybe I will just remain this one. Okay. I will do it next. Devrun. Echo.js. Trigger subject. Or echo. That means that the function will be invoked when it's deployed. It will be invoked on the echo subject. And I will specify the type of the function is v8. We'll come back to this later. Okay, so we see something happen on the next node. This is basically a Firecracker VM that has been run with this workload inside of it. And also the next CLI returned this message saying that the workload was accepted. So now we can go to the client side and just try to publish something in the echo subject. Whatever, hello. Pub is not the right one because I'm expecting a reply. So I need to use NATS rec. This is also why I talked about this request reply before. And here I can see that I have the reply from the function. So quite easy. I have a function in JavaScript. I just deploy the function, and I can invoke it just by sending a message on a specific subject, on the subject that is related to this function. Another example with a wasm function. The thing is, JavaScript functions are quite limited currently in NEX, because they are relying on a specific library, which is v8go, which is the way to run JavaScript with Go. And because of this library, we can't do all the things that we may need to do in those JavaScript functions, like, for example, importing some external libraries in the function. So if you want to go to do some more advanced stuff, you should probably go in the WASM path, where you can, for example, have your function coded into Go, Rust, or whatever. You build your function at a statically linked binary, and then you can deploy this function easily with NEX. In this example, this is a simple function that will just echo what it receives. It was already built the function in WASM32 WASI targets, so I can just deploy the function the same way I've done for the JavaScript function. This is what I will do. I will go into the I will go into the WASM here folder. I will do a next dev run. Target is WASM WASI, and then release. Then the binary is this one. I need to provide the whole path toward a binary, and then I will specify the subject on which the function should be invoked. Let's go with echo WASM, echo WASM, and the type here is WASM. Okay, so the function was deployed. I can go to my client, and I can do the same thing. I will just set whatever payload on this new subject, and I get a reply from the function. So here, this is just another type of function, binary that has been compiled and that I can deploy very easily with NEX. The JavaScript function, so they are quite limited, as I said, but they can access the host services. The host services means that they can access the NATS communication layer, they can access the KV store, the object store, and they also have access to an HTTP client, which is quite handy. So this gives some additional capabilities to the JavaScript functions. This is an example, so you don't have to go through all this code. It's just an example of telemetry.js. The idea is to show a function that uses those KV store, object store, and also the HTTP client. So basically, telemetry.js will say this kind of function waits for payload coming from, let's say, IoT devices. And those payloads should contain the device ID and the temperature. So let's say that we have a couple of IoT devices that regularly send the temperature of their environment and their identifier as well. If we deploy this function, we'll do it in a couple of seconds, we will then use some test payload. And each payload received by this function will be, the device ID and the temperature will be extracted from the payload, and then the function will store inside the IoT devices KV store and also inside the IoT history object store the content of the payload it receives. It's really just to show how a function can use these host services to store data. And also, this function can send an alert, for example, if the temperature is greater than 30 degrees. So I will deploy this function. Telemetry.js, so I will do the same thing, next dev run. Telemetry.js, trigger subject. This time I will specify the devices.star. That means that all the messages sent to devices.something will trigger the function. And this is a function of type v8. Okay, so the function was deployed. I can go back to my client. And I will do a NATS rec. So I will set a message on this devices.123 for example, and I will send a payload. Can send a payload, a JSON payload quite easily. Here, devices ID, let's say 123, and temperature 25. Yep. And here, I get a reply from my function. What is interesting is if we have a look at the KV store. That's KV ls. Forget about this one. I will come back to this later on. NATS KV ls, I can have a look into these IoT devices. Sorry, IoT devices. Yep. I can see that inside this KV store, I have two keys. So this is a test one I've created quite a long time ago. And this was the one that was created just a couple of seconds ago. So I can get this key from the KV store. So I got the content of the payload that is returned. And I can do the same thing into the object store, object ls. There is the IoT history that has been created. The next CLI files that you can see here in terms of buckets is used to store the function, the function that are then deployed to NATS. So NATS inside this object store save the function that needs to be deployed. It's internal. So I will just do the NATS ls IoT history, and I can find here the JSON file that has just been created. I can get this file. Oh. And so I can see the content of this file that I retrieved locally. This is the content of the payload that was received. Just for you to understand that the function has access to this KV object store and can just put some content into this storage layer. I have another example for that. I have used the NATS client to populate one of a bucket into the KV store with some, as you saw, kind of stupid jokes I found on the internet. And I have a function which only purpose is to read this KV store and return one of these jokes in a random way. This is this kind of function, this one. Yeah, basically just to show you that we can have some external processes putting stuff into the KV or object store, and we can have a function that is allowed to read those content from the KV store. So here the function will not do very interesting thing, but just to understand that it can read something that has been created by another process. So what I can do is go back into here, next, step run, jokes, trigger, subject, equal, let's call it fun. You'll see it's not that fun. V8, yes. Okay, so the function has been deployed. By the way, just before invoking the function, we can use the next node ls, for example, which shows all the nodes. I just have one in my demo, and you can see the workloads that are deployed. So 4 workloads because I've deployed 4 functions. Okay, and then I can just do a NATS rec on the fun object, subject, and whatever. So it's not that funny, to be honest. But yeah, you understand that the thing is just to show that I have an external process. It has populated content in my KV store, and then I have a function that is allowed to read from this KV store. So this was the access to the host services. We can deploy functions, as we saw with NATS, but we can also deploy services. I will not do it, but it will be done pretty much the same way, except that the services, when you deploy services, you don't specify the subject that it will be triggered on, because the service is a long-running process, and it has already everything implemented into this code. But when you deploy the service, you can provide some environment variable to configure the service. So you will do it pretty in this way. You have echo.go that you need to statically compile, and once the binary is created, you can do a next dev run, and you just deploy the service, and you can invoke the service on the subject that the service is expecting. It's pretty much the same thing as for the functions. What is the status of NATS? Currently, this open source, this is open source version I use, obviously, is experimental. So if you want to try it, be careful, the API may change. It's interesting to know that there is already a commercial solution available that is built on top of NATS. This is what Synadia offer in this Synadia cloud offering. So it's just for paying customers. They call it workloads. That is something that is built on top of NATS. And it's interesting because with the workloads, you can deploy containers from images and also JavaScript functions. The current limitation of the OSS version, the version I'm using in this demo, is the 030 RC1, so release candidate. So it's not something that is released yet. I'm really looking forward to have the 030 released. Currently, the node needs to be managed manually. There is, in the JavaScript runtime, some constraints due to the V8 Go. So this is quite annoying because when you deploy your JavaScript function, you can't import some library from the external world, so it's quite limited. This is why you need to go the WASM path if you want to have some function with some advanced capabilities. And I found it was not that easy, but maybe it's just me, to debug the workloads. At some point, I had some function with some I added some logging into my function, and I was not really able to find those logs and to debug the thing. What is coming next, according to the documentation? The OCI image support. So that will be very good to have that because it will allow to run functions directly from a container image. That would be great. Do you need to have a look into NATS? I mean, is it worth exploring for you? Well, if you are comfortable with experimental technology, it could be good because it's still experimental. This is what is written in the documentation. If you're already using NATS, that could be a good fit, just at least to try this next feature. If you are building event-driven or IoT application, that could be also a good fit. And if you are looking for lambdas kind of functions triggered by NATS messages instead of HTTP, it could be a good fit as well. Probably not a right fit if you are using monolithic applications, if you are doing some simple CRUD verbs over HTTP, or if you don't have any streaming or event requirements. Not a good fit. So takeaway of this talk, NATS is evolving from communication layer, storage layer, and now the execution engine. Next. So NATS can run services and functions. Experimental, but I think promising. And it's easy to try. If you want to try it, you can go to the NATS documentation. You can ask a question in the NATS Slack channel. When I prepared the demo, I asked a couple of questions in the NATS channel because also I used the release candidate. It was not the easiest path. But I had even the next maintainer that replied to my question, and that was really helpful. And you can also check the next GitHub repository. Do you have any questions? 49.
We're there. The manufacturer Synadia recently had a legal battle with the CNCF over the trademark and threatened to withdraw it. That has been somewhat solved, but where do you stand on that? And it would make me doubtful betting on this project.
Yeah, so you're talking about the what happened recently with Synadia in the CNCF, the argument kind of, they wanted to go out of the CNCF, something like that? Yeah.
Yes, exactly
Yeah.
that.
So I think this is fixed now. I don't know, well, I can't tell you much about this kind of argument they have. But yeah, I think things are clearer now. NATS is still a CNCF project. I hope it will remain a CNCF project from quite some time. I'm not, you know, I don't know a lot about this argument that they have together, but you mean maybe you're talking about the confidence that you can have in the project when you see this kind of argument?
Yeah, well, they were kind of the sole developers of the entire project, so and when it makes me doubtful betting on it or if I should really use it unless I really want to go full in commercial.
Well, yeah, I'm not able to tell you much more about that because I'm not in the, well, NATS, I'm not involved with Synadia, so I don't really know what's exactly the issue with that. But I understand that it can, yeah, you can have some concern with that. But for me, NATS is an open source project since quite some time. They have some disagreement with the CNCF. Now it's fixed, so hopefully it will remain in the CNCF and the open source will still keep on evolving.
I have a short question regarding the functions. So you said it's nice to deploy Lambda-like functions, but from what I understood, it launches the Firecracker VM and that's running at all times, no? Or is it the Firecracker VM launched on trigger? Because otherwise you don't have improved compute density, right?
Yeah, yeah. Well, the overhead of the Firecracker macro VM is not that much. So yes, if the function is deployed, the VM will be there. Yeah.
Thank you.
Several questions. How are these key value and object stores persisted? Is it a file database? Can you define how many replicas of your object should be stored? And is there a backup restore possibility?
You have a lot of configuration that you can do at the Jetstream level for the messages first, and then also the KV and object store. There's a lot of configuration you can do to ensure the number of replicas. And the KV and object store, they are stored in the Jetstream nodes. So if you have a NATS cluster with, let's say, 3 nodes, all nodes forming a cluster, you have Jetstream enabled on all nodes, and the data will be stored on all the nodes. So you have some configuration option that you can use to specify the number of replicas you want, and yeah. But be careful. The object store, for example, is not something to be compared with S3. It's more internal to the nodes. It's not the same use cases, I would say.
Are there more questions? Yes.
Thank you for the talk. Is there an SDK for developing WASM function with Rust or Go that you have some kind of helpers to access key value store and these kind of things?
No, in the documentation is really about having the JavaScript function accessing the host stuff, but you can find, well, I mean, regarding the host services, but in the SDK you can find for NATS client, Java, Go, Rust, whatever, you will definitely find what you need to save or read things from the KV and object store. I mean, yeah, sorry, I didn't get your question right from the beginning. But when you're talking about functions, yes, you can use the NATS SDK.
So
definitely.
I don't mean the normal SDK. I mean more like from within the function, how you can access the thing which is exposed within WASM. You know what I mean?
Yeah, from the KV and object store, you mean?
Yeah, like for example.
This is not something I've tried, to be honest, because in the documentation it's more about the JavaScript function have this kind of functionalities because of the limitation they have, I guess. So if you go into the WASM way, if you use Go and Rust, you will be able to use the official Go and Rust SDK to access all those components. Yeah.
Okay, so thank you very much, Luc, for your talk and your insights. A lot of exciting technologies for me as well. I have to dig into those deeper too. And with that, another round of applause for Luc, and thank you.
Thank you.
And we will be meeting here in 15 minutes again for the next talk, 3:45. See you around.